Okay, I just want to talk briefly about the in-class exercise for today. So this is, of course, posted on the website, but in the first part of the exercise, you're asked to create a PenIO class demo, and then using the schematic in the docs platform schematics directory, find the corresponding uh, connector pin that drives LED 1 on the board. And then so make a copy of the source code in your Hello World program, and modify that so that it uses the PenIO class to turn on and off the LED. So it should turn it on for 3 seconds and off for 1 second. So you can use the tick timer function for the delay, and then don't forget to include the pen.h header file in order to use the PenIO class. So again, so refer to the lecture notes, refer to the schematic to figure out what pen name that you have to use, and then use the PenIO class, those high-level functions, to turn the LED on and off. And then for simple modification of that, also using the PenIO class, refer to the schematic to see which connector is connected to switch 8, the dip switch, and then have the LED reflect the state of the switch. So when the switch is on, the LED should be on, and when the switch is off, the LED should be off. Check the switch status and change the LED state every 1/10 of a second. So again, use OS time delay. I also put up an example of using the DMA timer. I'm giving you example code. You can maybe kind of figure out what it does based on the code I've provided. The code is based on the application note, and I'll provide a link to the application note. I don't think you need to read the application note to do this exercise, though. I'll provide the C++ code, so create a new project and then just run this code. You'll see that one of the values that's set in the code is equal to 3685. That's the reference value for the DMA timer. That corresponds to an interrupt of 50 microseconds. Now, I use a time delay of 1 second, and then am incrementing a counter every time the interrupt routine goes off. So every second, you should see that count increase by roughly 20,000. It's not quite exact, maybe 20,001. But I think that's the best resolution you can get. You might play around with this value a little bit to see if you can get it exactly equal to 20,000. But I think that was about as close as I could get. And then modify the program. You don't have to create a new project, so that the timer interrupt occurs every 1 millisecond instead. So that's a simple modification to this timer reference register value here, and then when you run the program again, you should see the count increase by approximately 1,000 because you're getting 1,000 interrupts per second, or 1 interrupt every millisecond. No new project yet. So we'll actually start looking at something different next time. We'll start looking at starting to do some networking with the NetBurner. So first I'll actually talk about networking at a high level, and talk about in particular how TCP/IP networking works before we actually start diving into code with the NetBurner.